So now we want to talk about how we place the database and the database software in relative to the other aspects of the programming environment that we're going to build. And we're going to talk both about large projects and small projects. And a large project would be sort of a website, like maybe you build a website to track comic books or something, and you store all the data in a database. And so in a large project, and we're not going to do it so much in this class, but I figure it's time, now that we're learning about databases, to sort of give you a sense of how they're used in these online systems. And maybe in a future course, you'll see how they're used learn how to do this in large projects. But there are generally sort of two roles. One is the person who writes the application and produces the user interface for the application and for the website. And then there's the other that actually sort of monitors and adjusts the database. And that person is the database administrator. Often in a large project, you will get some advice as an application developer from a database administrator. And the idea is the database tuning and monitoring is a somewhat specialized job. And so in a professional environment like the open source learning management system that I work on named Sakai, in production, I don't get as a developer, so that's who I am. This is me. I'm a developer. I write cool code. I make really neat widgets for the end user, and this is the end user in a web browser talking to my cool thing, and I add a little button and stuff like that. And I write code that actually talks to the database server, which is both code plus the data storage itself. And I write code that talks SQL to the database server and gets data back and then formats it for the end user. And that's what developers do. They are the ones that create application software. The database administrator, generally we don't let the developer talk to the database, the production database, directly, because we're afraid the developer will break it. And that's probably because there's been a lot of experience where developers broke it. So we have a special person called the database administrator. And they're the ones that are allowed to talk to the database. Now, because the database is both storage and software, it can take SQL queries from many different sources, both the application or database tools. And so the database administrator has like a direct way to talk to the database and get data back. And so if something's going wrong, like it's gotten really large, what's going on? So the database administrator will start running commands straight to the database, whereas the developer generally has no access to the real database. Eventually we can write a new version of the application software. And so that's kind of the split between the roles between developer and database administrator in large projects. And the database administrator does helps with the design and implementation, and often a database administrator is shared across a number of software projects. But that's not exactly what we're going to do, right? So it'd be nice, maybe you have a job, maybe you do have a job that there's a database administrator and it'll kind of look like that. But right now, during this class, we've met the database administrator and the application developer, and they're both you. Okay, they're both you, or me, right? And so what's going to happen now is you get to do both roles. And later, if you have somebody to help you with it, you might turn more into the developer side or more into the database administrator side. That's perfectly fine. So we still have a database system, right? And that's got both the logic, the software that makes the database smart, and the data itself. And we talk to it. And the program we're going to use initially right now is we're going to study the DBA way of doing business. You're going to write SQL, you're going to talk to this little piece of software that's going to submit stuff directly. And so you are going to act as a database administrator. We're going to create tables, put data in them, and we're just going to type stuff in to this application called SQLite Browser. There are others of these applications that are like database administrator applications. Much later, we are going to start writing Python programs. And in those programs, we're going to talk to the same database files using SQL. And we're not going to write programs that have a web interface. That would be like Twitter or comicbookregistry.com or whatever. We're going to have various sources of input, sometimes files, sometimes network. And we're going to write programs that read this stuff and clean it up. Often there's a cleaning step. And then we are going to write the data into a database. And so we're going to grow this data, fill it up, and then we'll sort of be done with this phase of acquiring data, and all our data will be sitting in a database. Then we will write another Python program to read this data and maybe make a pretty file. And even later in the class, we will be visualizing that or sending it to various other places. You might send it to R to do statistical analysis, or Excel to do some simple analysis or visualization, or we'll use JavaScript to make pretty pictures and spinning things and whatever. So the basic pattern here is it's the same. We're going to have sort of apps, and then we're going to have DBA, but they're both U. So the thing we're going to focus on first is right here. The database we're going to use is a thing called SQLite, and the software we're going to use is what I told you to install right at the beginning a while ago. Hopefully you've done that, SQLite browser, because otherwise you can't talk to the database unless you have something equivalent to this, and they do exist. But the basic pattern is read data, clean it up, stick it in the database in a sensible and organized way, and then write other applications to make sense of it and analyze the data. And that's what we're going to be doing coming up. So when we build this data, I mentioned the word schema, right? That we come up with a contract for exactly the way the data is supposed to look. And with this contract, the database software can make the best use of itself, right? It can make good use of the disk drive. It can make good use of all these other things. And so we call this the database model, and it's best thought of as a contract. Okay, we're going to talk into this file. There's going to be magic things that are stored in here. We use this database software. And the schema is our way to inform the database how we think this, how we're going to use the data and let the database figure out the way to play it, where to put it. I'll put this thing over here. I'll put another thing over here. And I'll put a little shortcut over here. We don't care about that. We say this is the data model we're going to work with, and you, the database code, are supposed to be really smart and figure out how to make the most sense of that. So the data model is not just the SQL to query it, but the data model is our contract about the shape of what we're going to store and retrieve in our database. So there's a number of common database systems. I've mentioned several of them. Oracle is awesome. It's a company that was effectively created just to make a database system. And they were founded at the birth of the relational movement and won because they were very good at it. The others who didn't win were like IBM and others, although they all have relational databases as well. A lot of those other vendors I don't know if letting Oracle win is the right word, those vendors that that Oracle outcompeted were the ones that didn't embrace this relational stuff. Because I was in college when they saw it was coming down, and some of us were like, relational, too much math, give me the quick, dirty stuff, right? And it took a while for the relational model really to win, but when it won big time. And Oracle was a company that made a bet on it winning. And so by the time we all realized, whoa, it's a good idea, because we all thought it was a bad idea, or at least I did, it was too late. Oracle had the best implementation of the good idea that we all finally realized was a good idea, and so Oracle kind of wins. So then what happens is Oracle's kind of the old dog in the marketplace, the very expensive commercial. A lot of people think it's simply the best, but there's alternatives that are quite nice. There's MySQL, which is an open source. MySQL has been purchased by Oracle, but continues to be open source. If you really want to be open source, there's a MySQL MariaDB. MariaDB. It starts with an M on purpose so that it starts with the same letter as that. And so MariaDB is a copy of the open source version of MySQL, which was made at the moment that MySQL was purchased by. But MySQL remains open source, so a lot of people who use MySQL are switching to Maria, but a lot of people just keep using MySQL. And if Oracle does something bad with MySQL, we'll all switch to Maria, and that'll be the end of that. So at that point, Oracle hasn't done anything really bad with MySQL, and so it's okay. So we tend to use MySQL for online websites, a lot of website stuff. Oracle tends to be used for enterprise kinds of things. And then another one that's very popular is SQL Server. It's the Microsoft one. You may have even used Microsoft Access, and you might have even done like a screen where you're dropping things down that turn out to be SQL under the covers. Don't know. SQL Server for Microsoft is a very good product. Some enterprise organizations are all Microsoft, and so they use SQL Server. Don't feel bad. Pretty much everything I'm going to talk about applies equally to SQL because SQL is a standard, and that's nice. There's another one called Postgres that's also open source. That's very nice, and it's kind of more of an imitation of Oracle than MySQL. MySQL is designed to be simpler and faster and solve less problems than Oracle, but do them super fast, and that's why it's often very popular in websites. Postgres is sort of more of a rich database that's very, very much a direct competitor to Oracle. MySQL is its kind of own world, and we're not going to use any of these. If you go take sort of a web class, you will probably use MySQL, and everything I'm going to teach you in this class is useful there. Okay, all the knowledge, all the SQL, but we're going to use a thing called SQLite. Light meaning little, tiny, not very heavy. And so SQLite is what's called an embedded database. And MySQL or Oracle are whole pieces of separate software that we sort of talk across a network connection to. But SQLite is actually part of software. And so it's built in. Your car, if it's a reasonably modern car, probably has 5 copies of SQLite in it, right? So your car has SQLite. If you have a fancy music player in your car, it probably is using it. If you have an iPhone, it probably has 30 copies of SQLite in it. Because SQLite is designed to be really small, so small that you actually don't have to separate it, you just build it into the application. And the thing that matters most to us is that it's built into Python. It's already there in Python. So that's super awesome, right? And it's fast and aimed at smaller amounts of data, but because in Python we're doing data analysis, we will make good use of SQLite, and the fact that it's built in just makes our life really simple. We don't have to install a bunch of software. Python has it with nothing more than an import statement. You know how this story goes. If you're in Python and you got to get something done, the first thing you do is figure out what import statement you need. Okay? So that gives us a sense of the SQL applications that we'll be using. Up next, we're really going to start writing some SQL, make a database and put some tables in and put some data in those tables.